Imagine a civilization so advanced that it no longer depends on planets, fuels, or stars from afar. Instead, it builds a colossal structure around its own sun, a megastructure so vast, so powerful, that it captures nearly all the energy a star can produce. This is the Dyson Sphere, one of the most extraordinary ideas humanity has ever imagined. Welcome back, traveler. Tonight, we step into the mind of a Type 2 civilization and explore a megastructure that could change the fate of any intelligent life. To understand a Dyson Sphere, we must imagine the unimaginable. Our sun emits enough energy every second to power human civilization for millions of years, but we capture only a tiny fraction of it. A Dyson Sphere is the idea of building a giant shell or swarm around a star to collect nearly all of its power. The concept was first proposed by physicist Freeman Dyson in 1960. He imagined that any advanced civilization wanting to grow beyond planetary limits would eventually build megastructures around their stars, not as a single solid shell, but as millions of independent collectors forming a stellar-scale swarm. A complete solid shell around a star is almost impossible. The material needed would exceed everything found in our entire solar system. But a Dyson swarm, millions of coordinated solar collectors orbiting the star, is far more realistic. Each one catching sunlight, storing it, and beaming it to the civilization that built it. In the Kardashev scale, a method of measuring civilization advancement, a Dyson Sphere belongs to a Type 2 civilization. This is a society capable of harnessing the full energy output of its star. Humanity isn't even Type I yet. We barely use a fraction of the energy available on our own planet. Why would a civilization attempt something so colossal? Simple energy. Every technological leap requires more power. Space colonies, artificial planets, interstellar travel. None of these are possible without unimaginable energy. A star is the ultimate power source. A Dyson Sphere unlocks all of it. But even a Dyson swarm demands more material than any single planet contains. A civilization might dismantle entire asteroids, moons, or even Mercury to build enough collectors. Solar mining, robotic extraction, autonomous factories. Everything becomes automated on a cosmic scale. Building millions of collectors orbiting a star requires perfect precision. Each piece must avoid collisions, maintain orbit, and coordinate energy transmissions. This is engineering not at human scale, but at stellar scale. A Dyson swarm is a symphony of synchronized satellites orbiting in perfect harmony. A star is not a quiet neighbor. Solar storms, coronal mass ejections, magnetic waves. Any of these could destroy collectors. A Dyson swarm must be flexible, resilient, and self-repairing. An advanced civilization would build machines that rebuild themselves faster than a star can tear them apart. We are far from building a Dyson Sphere, but early steps exist. Solar power satellites, orbital mirrors, asteroid mining concepts. If humanity spreads into space and becomes a multi-planet civilization, a Dyson swarm may become an inevitable future. But this raises a deeper question. If Dyson Spheres are such a powerful idea, could someone out there have already built one? And if they did, how would we even know? If a civilization ever built a Dyson Sphere, its star would no longer shine the way we expect. The visible light might dim, or even disappear, but the heat, the infrared glow would still leak out. So astronomers began searching the sky for stars that look strangely dark, yet still radiate heat. And that search led to one of the most mysterious objects ever found. A Dyson Sphere doesn't hide a star completely. It transforms the star's bright light into usable energy and re-emits waste heat as infrared radiation. This creates a unique signature, a warm, infrared glow without the usual starlight. If we ever see this pattern in space, it could be the first evidence of an advanced extraterrestrial civilization. In the last decade, Astronomers have scanned millions of stars using infrared surveys like WISE. Most stars behave exactly as physics predicts, but a few do not. A handful emit strange levels of heat that don't match their brightness. And one star in particular shook the scientific world. Tabby's star, also known as KIC 846-2852, became famous because it dims in unpredictable, dramatic ways. Up to 20% of its light vanishes for days, then returns suddenly. Planets can't explain it. Dust doesn't fit the data. Some scientists wondered, could this be the shadow of a partial Dyson swarm? While natural explanations remain likely, the Dyson Sphere idea brought global attention. It wasn't proof, not even close, but it became the first real-world candidate where astronomers openly asked, what if this is not nature, but engineering? A Dyson swarm wouldn't dim a star evenly. Each collector would cast its own shadow as it passes between the star and a distant observer. These shadows could create irregular dips, just like the ones we see in Tabby's star. A megastructure might reveal itself not through light, but through darkness. If an alien species truly built a Dyson sphere, it would imply they reached Type 2 on the Kardashev scale. This level of advancement requires mastery of robotics, space mining, megastructure construction, and energy systems far beyond anything humans possess. But it would also mean their technology is visible across light years. Astronomers now search for technosignatures, signals not from nature, but from engineering. Waste heat, unnatural orbital patterns, non-random dimming, structure-like shapes, or even radio beams stabilizing swarm collectors. A Dyson sphere could reveal itself through any of these footprints. Before we look for alien Dyson spheres, we must ask, could humans ever build one? Theoretically, yes, but it would require dismantling Mercury, mining asteroids, building billions of autonomous satellites, and constructing orbital factories bigger than countries. The challenge is massive, but not impossible over thousands of years. Coordinating millions of collectors requires advanced AI. Even one collision could trigger a chain reaction demolishing half the swarm. But self-repairing machines, adaptive orbits, and quantum communication networks could synchronize the entire structure like a cosmic ballet. A completed Dyson swarm transforms a star into a controlled artificial power plant. The civilization becomes independent of planets. Energy shortages vanish forever. Their technology, power, and infrastructure expand faster than any natural world could allow. But what happens next? What does a civilization do once it has the power of a star, and energy becomes infinite? Do they build new worlds? Create artificial universes? Travel beyond their galaxy? To find out what comes after a Dyson sphere, we must look beyond imagination and into the deep future of intelligent life. When a civilization controls the power of an entire star, its limits change forever. Energy becomes infinite, technology becomes unbounded, and the line between nature and engineering begins to blur. With stellar-scale power, a civilization could create artificial planets, massive habitable spheres built from reclaimed asteroid material. These worlds could have perfect climates, controlled gravity, and oceans sculpted by engineering. Entire populations could live in these megastructures, orbiting peacefully within the star's energy field. Some theories suggest an advanced civilization could perform star lifting, the process of removing material from their star to create new resources. Hydrogen, helium, exotic elements. The star becomes an energy factory and a matter reservoir. In this stage, the star is no longer a natural object, but a carefully managed power source. Once a civilization commands its star, it could even move the star. Theoretical machines called stellar engines could steer an entire solar system through the galaxy. This would let a civilization avoid cosmic hazards, escape dying galaxies, or simply explore, carrying their home star with them. With unlimited energy, interstellar travel becomes routine. Dyson-powered ships could travel between stars, carrying knowledge, biology, and technology across light years. The civilization transforms from star-bound to galaxy-bound. Each new system could become the seed of another Dyson Sphere, expanding the reach of intelligent life. Imagine a galaxy where thousands of stars host Dyson swarms. Their combined energy outputs form a vast interstellar network, a web of light and information stretching across thousands of light years. Communication beams travel instantly. Resources flow between systems. The galaxy becomes a single interconnected civilization. On the Kardashev scale, a Dyson Sphere marks the rise to Type 2. A civilization expanding its power to entire galaxies enters Type 3. A society so powerful that individual stars become tools and galactic energy becomes the new standard. In this stage, the civilization becomes nearly immortal, capable of surviving cosmic catastrophes. If civilizations can reach this level, where are they? Shouldn't we see galaxies lit by Dyson spheres? Some astronomers believe we already might. Certain galaxies appear strangely dim in visible light but glow unusually bright in infrared, just like a Dyson-enclosed star. But the evidence remains incomplete, mysterious, uncertain, and exciting. There is a possibility that advanced civilizations don't want to be seen. A Dyson sphere absorbs light, but also hides life. Entire star systems could be invisible to us, wrapped in engineered darkness. The universe may be full of civilizations disguised behind megastructures, quiet, efficient, distant. With access to stellar energy, a civilization might survive the death of its star. They could dismantle it, move it, or replace it with artificial power cores. Even as the universe fades billions of years from now, a Dyson-powered species could endure. They might outlive galaxies, and perhaps the universe itself. A Dyson sphere is more than a megastructure. It is a symbol of what intelligence can achieve when it refuses to be limited by nature. Somewhere out there, among billions of stars, a civilization might already live inside one, thriving in the light of a captured sun. And if a Dyson sphere represents the engineering of a star, what happens when a civilization tries to engineer space itself? Next time, we explore the strange and powerful concept of wormholes, gateways that may reshape the way we travel through the cosmos. Traveler, our journey across the stars never ends. Stay curious, and I'll see you in the next cosmic horizon.